Good morning, guys. I have never done this sort of thing before, so bear with me. What I've decided to do is to supplement the stuff that I sent you with, from time to time, a little video lesson. So this is the first one, and we're going to take a look at linear relations. I'm going to try and stay out of the frame so that all you can see is the lesson and not my strange face. Anyways, let's get started. So a linear relation is simply a relation that when you graph it, in other words, when you plot the ordered pairs, it forms a straight line when you join the points. Okay, so this one's linear, this one's not. So when you graph it, it's really easy to figure out whether or not you have a linear relation because you get a graph that's a straight line. Okay? It's not quite as easy if you're given a set of ordered pairs. And remember, ordered pairs are simply x and y coordinates that can be plotted on a graph. So the x and y coordinates, or the ordered pair for this particular one, would be 2 for the x and 6 for the y. And when you plotted it, you would get a point. So if all we have is a set of ordered pairs, then we have to take a look at how the numbers change as you go down the list to figure out whether or not you have a linear relation. You have a linear relation if the change as you go down from one to the next is the same. And as you can see, for my x values, I'm adding 2 each time, right? 0 plus 2 is 2, 2 plus 2 is 4, and so on. The same has to hold for the y values. So as you can see here, you're going up by the same amount each time. So this one is linear, okay? For this one, when you check the x values, you see it's going up by 2 each time, right? So far so good. Make sure you check both. When you check your y values, you see that doesn't apply. You're going up by 4, and then you're going up by 20, and then you're going up by 100, and so on. So this one, not linear. Now, if you're given an equation, then all you need to do is check the degree. Remember, we talked about degree in the polynomials chapter. If the degree of your equation is 1, then you're good. It's a linear relation. And remember, the degree is just found by looking at each term and seeing what's the greatest exponent on any one term. As you can see, all of these variables have exponent 1, and that's why they're all linear. If you take a look over here, you can see an exponent of 2, so this would be degree 2. This one, remember, since they're multiplied, you have to add the exponents. This would also be degree 2. And this one is degree 3, and that's why these ones are nonlinear. If you were to graph them using your graphing calculator, and there are instructions for that in the module stuff that I sent you, if you were to graph these, you would not get a straight line, but if you were to graph these ones, you'd get a straight line. So some examples. It says determine whether they're linear or nonlinear, and again, that's pretty straightforward. You can see you have an exponent of 2 here, so this one is nonlinear, whereas here, all the variables have an exponent of 1, so it is a degree 1, so yay, it's linear. If you're given a set of ordered pairs, Remember, that's just like when you have a table of values. You simply look and see, how are my x's changing and how are my y's changing? If they're changing by the same amount, then you're good. Okay? So as you can see, from one x to the next, you're going up by 4. From one y to the next, you're going up by 1. Since the x's go up by the same amount each time as do the y's, this one is a linear relation. Okay, so this one is linear. And again, remember, you just check by seeing how much the x's go up by, how much the y's go up by. Sometimes a relation can be described in words. Okay? So, for instance, for our first one, if we're trying to decide whether it's linear or not, we have to ask ourselves, what's happening here? Well, what you're looking at is you're looking at distance related to time. So we can generate a set of ordered pairs. If this thing is going 10 kilometers an hour, well, we can say that at 0 hours, we've gone 0 kilometers. At 1 hour, if we're going 10 kilometers an hour, we've traveled 10 kilometers. 2 hours, 20 kilometers, and so on. Okay? Well, our x values are going up by 1 each time. Our y values are going up by 10 each time. So because we're going up by the same amount with our x's, plus 1, and our y's, plus 10, and so on, we can say, yeah, this one is linear. Okay? With this one, we're comparing the area of a square with the side length of that square. So, if we're comparing side length with area, then if our side length is 1, our area is 1 times 1, or 1 unit squared. If our side length is 2, our area is 2 times 2, 4. If our side length is 3, our area is 9, and so on. That generates another set of ordered pairs. Our x values are going up by 1 each time, but look at our y values. Our y values are going up first by 3, and then by 5, so this one is non-linear. Okay? Okay. Discrete versus continuous data. I'm not going to take too long to go through this simply because it's a fairly simple concept and you do have this stuff in the assignment I've already sent home for you. Discrete versus continuous data. All you have to ask yourself is, are there meaningful data points between what you've been given for data? If there are meaningful data points, then it's continuous. So when we're doing things like talking about time or mass, in general, if we're talking about things that can be measured, then you're dealing with continuous data. If we're dealing with things like objects, that tends more often to be discrete. So if we're graphing, for instance, the cost of a number of DVDs that you might buy, or the cost of a number of t-shirts that you might buy, that would be discrete data, because we can't have things like 1.5 t-shirts. Okay? Continuous data, stuff that's measured, so for instance, if we were graphing distance versus time, both distance and time are measured, You can have values between the points. So for instance, I can have 1 hour or 1.1 hours or 1.2 hours. I can have divisions between 1 hour and 2 hours. Whereas with discrete data, I can't have divisions between 1 t-shirt and 2 t-shirts. Okay? If we're counting the number of people in Alberta over time, we certainly can't have partial values for people. That would get very messy to have 1.5 people. So just a couple of examples. Suppose a student drew a graph of each function described below, which would be connected. So in other words, you connect the points when you have continuous data, but you don't connect the points when you have discrete data, simply because there is no in-between with discrete data. Okay? So if you're talking about t-shirts and letters, that would be discrete, because you can't have partial t-shirts or partial letters. Altitude, which again, remember, would be measured in meters or feet or kilometers, and time, which would be measured in seconds or minutes, that would be continuous, because you can have in-between values. You could have 1.4 kilometers or 1.5 kilometers. Okay? Mass of a baby and age, again, both of these are things that can be measured. So this would be continuous. Cube root of a real number and the number itself. Well, remember we talked about cube roots, and some cube roots are irrational. So you could make the argument that a cube root being irrational might be continuous or might be discrete. So we're going to skip D. I don't want to confuse you. Dependent and independent variables. Okay, this is just straight up definition stuff. You have a glossary in the materials that I've given you, so I'm not going to take any time to go through this. You can read it if you like. Okay? You can use words to describe a relation as well. Again, that's covered pretty well in the stuff that you're given. Just a reminder that generally if you're given a table of values or you're given an ordered pair, the x always comes first and the y always comes second. So this would be your x coordinate and this would be your y in an ordered pair. Okay? Just as the first value, the x value, is given in the first column and the y value in the second. Okay? Remember, the independent variable is always the x variable. The dependent variable is always the y. Okay? Finally, we can express a relation as an equation, and we generally default to using the same x and y that I just mentioned for tables of values, but not always. Okay? So sometimes when we have a word problem, we would express it this way. The important thing to remember, though, is the dependent variable is always isolated, and the independent variable, the independent variable is always on the right side of the equation with the rest of the numbers. Okay, so this is the independent, or x. This is the dependent, or y. Okay? When you're plotting points, and again, your lesson goes over this very well, when you're plotting points, the y or vertical axis contains the y, coordinates, and the x, or horizontal, contains the x. Okay? Remember, x values are positive to the right and negative to the left. Y values are positive as you go above the x-axis and negative when you go below the x-axis. Okay? So positive and negative values. I think we're going to shut this down. We've gone over this lesson. Maybe tomorrow we'll go through domain and range. Okay? So if you're having a little bit of trouble with domain and range, this tends to be something that students have trouble with. I'll do something on this tomorrow. Anyways, it was nice to talk to you again. Sorry I can't see you. Bye.